Good afternoon. Is it audible? Yes, good afternoon.
Good afternoon, sir.
Is it audible now?
Yes, sir.
Yeah, now. Yeah, coming to the compounding of plastics. Compounding of plastics are nothing but the process of adding additives to the resin. Okay, to uh, convert them into a desired, mold them into a desired form or desired shape. Okay, some polymers like polymethyl methacrylate. Okay, polymethyl methacrylate, polystyrene. Okay, polymethyl methyl methacrylate and polystyrene, etc., can be molded without application of additives. Additives is nothing but a process of adding chemical admixes. Okay, process of adding chemicals to make to proper forms. Okay, we can mold the plastic into the proper forms. We need to add some chemical additives. Okay, this process of adding chemical admixes which increases the physical properties of the plastics are known as compounding of plastics. Okay, here these polymers like methyl methacrylate, polystyrene, etc., can be molded without application of additives. Okay, without adding the additives, these polymers, these are can be converted into desired form or shape. But many of the plastics, plastic like phenolic and amino resins, and cellulose resins, etc. Okay, many of the plastics like phenolic, amino resins and cellulose resins, etc., require additives. Additives are nothing but chemical admixes. Chemicals required to convert them into the desired form or desired shape is nothing but uh, additives. Here, these require additives for the molding into proper forms. Okay, the compounds like the plastics like phenolic, amino resin, and cellulose resin, etc., require additives for the molding into proper forms. Okay, this the process of adding chemical admixes. Okay, chemical admixes which increase the physical properties of molded products. Okay, which increases by adding this chemical admixes which increases the physical properties of molded products is called compounding of plastics. Compounding of plastics. Now, what are the additives required to the added to the polymer resin? Here, resins are nothing but the major portion of the plastic is nothing but resin. Okay, the major portion of plastic, major portion of plastic. Okay, major portion of plastic is a resin. To this resin, we are going to add all these plasticizers, peelers, stabilizers. Okay, lubricants are nothing but oils, and accelerators are catalysts and coloring materials. Already you know that resins are of two types: thermosetting, okay, thermoplastic resin, and thermosetting resin. Thermoplastic resin and thermosetting plastic. Thermosetting thermoplastic resin and thermosetting plastics. Okay, here resins form the major portion of the plastics. Now see what actually these are the additives. Resins, plasticizers, okay, fillers, stabilizers, lubricants, accelerators or catalysts, and the coloring materials. Okay, these are the chemical admixes that are acts as a additives to polymer resin. Okay, it acts as a additives for the polymer resin. Additives to the polymer resin. Okay, compounding of plastics is nothing but the process of adding chemical admixes such that increases the physical properties of the molded products, which increases the physical properties of the molded products is called compounding of plastics. Now coming to the first one, that is resin. Okay, what actually the resin is? Okay, is that okay? What actually the resin is? Resin is nothing but a polymer. Okay, it is already I said that the major portion of the plastic is the resin. Here, it is a binder or polymer material which constitutes the major portion of the plastic. Okay, major part of the plastic is the resin. Major part of the plastic is the major portion or major part of the plastic is the resin. As already we discussed that there are two kinds of resins. One form of resin is the fusible and remoldable, known as thermoplastic. Okay, already you know that thermoplastics. Okay, we have discussed the differences between thermoplastic and thermosetting resin. Thermoplastic is the there in the polymer chains. Okay, whatever the bond that is present is the weak bond. Okay, weak bond is present. It undergoes breakage. Okay, and helps to ease the momentum of the polymers. Okay, on heating, this thermoplastic gets converted into the soft rubber, softener. Okay, and on cooling, this again it becomes it reappears its shape. Okay, again gets converted into the rigid, strong plastic. Okay, on heating the thermoplastic resin, the harder become softener. Okay, harder becomes softer, and on cooling it becomes softer. Become again it reappears to the harder, harder plastic or hard rubber. Here, as described earlier, there are two kinds of resins. The one form of resin is the fusible and remoldable. This is a remoldable plastic that is known as thermoplastic. And whereas other is the cross-linked, three-dimensional cross-linked non-fusible form of resin. Okay, three-dimensional cross-linked non-fusible form of resin known as thermosetting plastic. Okay, here this thermosetting plastic require the catalyst during the molding process. We'll discuss there in the during the discussion of catalyst. Here the thermoplastic resins require the catalyst for molding process. Okay, for molding process it requires the thermoplastic resins requires the catalyst or accelerators. Catalyst or accelerators. Here these are the examples: polyethylene resin and PVC, polyvinyl chloride. Okay, these are the examples for the resins, polyethylene resin and polyvinyl chloride. Okay, it forms the major part of the plastic is resin. As discussed that one form of the resin is thermoplastic and another form is thermosetting resin. Thermoplastics are those in which these are fusible and remoldable. We can convert this hard into soft, and again on cooling we are converting the soft to hard. This is nothing but remoldable type of thing. That is nothing but thermoplastic resin or thermoplastic resin. Here, whereas other form of the non-fusible form of the resin is known as thermosetting plastic. Here it requires the catalyst during the molding process. It requires the catalyst during the molding process. Example: polyethylene resin and polyvinyl chloride. Polyethylene resin and polyvinyl chloride are the two types of resins we have. Here coming to the plasticizers. What is the duty of these plasticizers? Okay, these are plasticizers are the chemicals that are added to resin. Okay, already I have said that all these plasticizers, peelers, accelerators or coloring agents, all these are we are going to add to the resin. Okay, here the resin forms the major portion of the plastic. Major portion of the plastic is the resin. Here chemicals that are added to resin to increase their plasticity and flexibility is called plasticizers. Okay, these are the chemicals that are added to resin to increase their plasticity and flexibility of the plastic or resin. Okay, these are the chemicals that are added to the resin to increase their plasticity and flexibility. Okay, plasticity and flexibility. Now coming to the plasticizers, molecules get what is the duty of this plasticizers is, okay, it moves inside the polymer chain. Okay, this plasticizers moves inside the polymer chain and neutralize the intermolecular force of attraction. Okay, it moves the neutralize the intermolecular forces, whatever the forces that present between the polymer chains. Okay, this plasticizers moves inside this intermolecular force of attraction between the macromolecule polymer chains. Now what is the duty of this plasticizers? Then it helps to breakage of, okay, breaking of intermolecular force between the polymer chains, facilitate the greater freedom for the momentum of polymer, greater freedom for the momentum of polymer chain, thereby increasing the flexibility of the plastic. Okay, as the when we add this plasticizer to the resin, what is the, it increases its plasticity and flexibility. How means, after adding this plasticizer, okay, it moves inside the polymer chain and it will neutralize. Okay, this plasticizer will neutralize the intermolecular force of attractions between the macromolecular polymer chains and helps to breakage of intermolecular force of attractions between the polymer chain, which helps to greater freedom, okay, greater momentum of the polymer chain, thereby increasing the flexibility of the plastic. Okay, flexibility of the plastic gets increases. As increasing the flexibility of plastic by addition of plasticizers reduces the strength and chemical resistance of the plastic. Okay, as increasing the flexibility of the plastic by adding the plasticizer. Okay, these are the chemicals added to the plasticizers, are the chemicals added to the resin to increase their flexibility and plasticity of the plastics. Okay, as increasing the flexibility of the plastic by addition of plasticizers reduces the strength and chemical resistance of the plastic. Okay, which it reduces the strength and chemical resistance of the plastic, chemical resistance of the plastic. Here most commonly used plasticizers are, okay, these are the examples. One is vegetable oil, and tricrysyl phosphate, okay, tricrysyl phosphate, and tributyl phosphate, tributyl phosphate, and triphenyl phosphate. Okay, these are the examples of plasticizers. Okay, here these are the chemicals that are added to resin to increase the plasticity and flexibility of the plastic. Plasticity and flexibility of the plastics. Okay, the most commonly used plasticizers are vegetable oil, tricrysyl phosphate, triphenyl phosphate, tributyl phosphate, etc. Here these are the tricrysyl phosphate structures. Here this is the tricrysyl phosphate and triphenyl phosphate. This is the triphenyl phosphate. Yeah, this is here what happens whenever this plasticizer, this is the color of this plasticizer is pink in color. Whenever this add to the polymer chain, okay, these are the polymer chains, it helps to breakage of the polymer chain and helps to the easy momentum of the chain takes place. Easy momentum of the chain can be taken place. Yeah. Next, coming to the fillers. What is the fillers now? These are the mixtures, molding mixtures. Okay, fillers are the materials that added to the molding mixture in order to give their better strength. Okay, better hardness, strength, and opacity and workability to the plastics. Okay, we are adding these fillers to in order to give their better hardness to the rubber. Okay, in order to give their hardness, strength, and opacity and workability to the plastics. Workability to the plastics. Here, filler reduces the cost of polymers. Okay, it reduces the cost of polymers and also reduces the brittleness of the polymer. Okay, some commonly special properties, some special properties exhibited by fillers are given below. If you add a carborundum as a filler and Wazat and mica are added to provide the extra hardness to the resin. Okay, we are adding this carborundum, Wazat and mica are added to give extra hardness to the resin, and barium salts are added to make the plastic impervious to the X-rays, and addition of asbestos provide the heat and corrosion resistance as a chemical. Okay, if we add the asbestos to this molding mixture, what happens means it helps to provide the resistance against heat and corrosion. Okay, as a percentage of filler is up to 50% of total molding mixture. Total out of the mixture that is present there, molding mixture, the 50% of fillers have to be present in the molding mixture. The most commonly used fillers are wood floor, gypsum, and sawdust, marble floor, cotton fibers, etc. These are acts as a fillers. These are acts as a fillers compounding of plastics. These are wood floor, gypsum, sawdust, marble floor, common fibers, etc. Cotton fibers, etc. acts as a fillers in the compounding of plastics. Okay, the fillers are the materials that we add to molding mixture in order to give the better hardness, strength, opacity, and workability to the plastic. Okay, it gives a molding mixture better hardness, strength, opacity, and workability to the plastics. Examples are carborundum, wazat, and mica are added to provide the extra hardness. Barium salts are added to make the plastics impervious to the X-rays. Addition of asbestos provide the heat and corrosion resistance. And commonly used fillers are wood floor, gypsum, sawdust, marble floor, and cotton fibers, etc. acts as a fillers in the compounding of plastics. Next, coming to the fourth type, that is lubricants. What is the use of these lubricants? Yeah, okay. Coming to the lubricants, lubricants make the molding of plastic easier. Okay, these lubricants are nothing but oils, waxes, and soaps acts as a lubricants. It makes the molding of plastic easier. Okay, they impart the it gives the glossy finish to the plastics or products. Okay, lubricants makes the molding of plastic easier. They impart the glossy finish to the products. Okay, here common lubricants which prevent the molding articles from sticking to fabrication equipment. Example, waxes, oils and stearates, soaps, etc. acts as a lubricants. Lubricants are nothing but which reduces the friction. Okay, by using these lubricants, it makes in the for the molding of plastic easier. Here, it helps in molding of plastic easier, and they impart the glossy finish to the products, and this prevents a molded article from sticking to fabrication equipment. Waxes, oils, stearates, and soaps acts as a lubricants in the compounding of plastics. In the compounding of plastics, waxes, oils, stearates, and soaps are used as a lubricants in the compounding of plastics. It helps to molding mixture. Okay, molding of plastic easier. It helps the molding of plastic easier, and they impart the glossy finish to the products. Glossy finish to the product. Next, coming to accelerators or catalyst. Okay, this is mainly added to thermoplastic resins. Okay, thermosetting plastics. Sorry, thermosetting plastics. Okay, this catalyst or accelerators are added to thermosetting plastics in order to accelerate the polymerization of fusible resin to cross-linked form during the molding operation. Okay, here what is the use of catalyst? Okay, the mainly added these accelerators or catalyst added to thermosetting plastics. Okay, these are added to thermosetting plastics in order to accelerate the fusible resin to cross-linked form during the molding operation. Okay, okay, why we are going to add to thermosetting plastics means it helps to easy movement or easy polymerization of fusible resin to cross-linked form of resin during the molding operation. Okay, the catalyst used in this process are hydrogen peroxide H2O2 and benzyl peroxide, and metals like Ag, copper, lead, Pb, and metal oxides like zinc oxide, etc. are used as a accelerators or catalyst. Okay, the main aim of this catalyst is it helps to convert the fusible resin to cross-linked form during the molding operation. Fusible resin to cross-linked form during the molding operation. These accelerators or catalysts are mainly added to thermosetting plastics. Thermosetting plastics in order to accelerate the polymerization of fusible resin to cross-linked form during the molding operation. Okay, the catalyst used in the process of are hydrogen peroxide, benzyl peroxide, metals like Ag, Cu, Bb, and metal oxides like zinc oxide, etc. Hydrogen peroxide and zinc oxide acts as a accelerators or catalyst in the compounding of plastics. Compounding of plastic, it acts as a accelerators or catalyst. Next, coming to the stabilizers. Stability, it gives the stability of plastic during the processing. Okay, what are the stabilizers here? Stabilizers are added to molding components to improve the thermal stability of the plastic during the processing. Okay, here we are adding the stabilizers to the molding components, to the stabilizers to the molding components to improve the thermal stability of plastic. Okay, to improve the thermal stability of plastic during the processing. There are two kinds of stabilizers. One is opaque molding stabilizer, and the second one is transparent molding stabilizer. There are two types of stabilizers we have. One is opaque molding stabilizer, and the second one is transparent molding stabilizer. Opaque and transparent molding stabilizer. Coming to the opaque molding stabilizers are mainly Okay, these are the salts now. Lead salts like lead chromate. Okay, lead chromate, white lead. Okay, white lead and lead silicate. Lead silicate, etc. are used in the opaque molding. Okay, lead chromate and white lead, lead silicate, etc. are opaque, used as a opaque molding stabilizers in the opaque molding stabilizers. Okay, mainly lead salts and here stearates. The transparent molding stabilizers are stearates of lead, barium. Okay, here stearates of, in the transparent molding stabilizers, stearates of lead, barium, cadmium are used as a transparent molding in stabilizers. Transparent molding stabilizers are stearates of lead, barium, cadmium, and are used as a transparent molding stabilizers. What is the use of these stabilizers means? Okay, the main aim is in the, we are going to add the stabilizers to molding components to improve the thermal stability of a plastic during the processing. Okay, it increases the thermal stability of the plastic during the processing. Okay, there are two types. One is opaque molding stabilizers and transparent molding stabilizers. Opaque molding stabilizers are lead salts like lead chromate, white lead silicate, etc. are used as a opaque molding, and the transparent molding stabilizers are stearates of lead, barium, cadmium are used in the transparent molding stabilizers. Now, last one is colorants. Okay, coloring agents we are added to the plastics. Okay, here colorants are nothing but coloring agents that are added to molded mixture. Okay, we are adding these coloring agents to molded mixture, which gives a desired color to the plastic, which gives a desired color to the plastics. There are again inorganic coloring pigments as well as organic coloring pigments or organic coloring dyes. There are two types. Colorants are two types. Okay, these are the coloring agents that are added to the molded mixture, which gives a desired color to the plastics, which gives desired color to the desired color to the plastics. These are of two types. One is inorganic coloring pigments as well as organic coloring dyes or coloring pigments. Coming to the examples for the inorganic coloring pigments, like inorganic pigments like lead chromate, okay, which is yellow in color, lead chromate, iron ferro cyanide dye, which is blue in color, aluminum silicate. Okay, these are the inorganic pigments: lead chromate, iron ferrocyanide, and aluminum silicate are acts as a inorganic pigments. Organic colorants dyes include phthalocyanine dye, which is blue to green in color. It acts as a organic colorant dyes. Organic colorant dyes are, which include phthalocyanine dyes. Phthalocyanine dyes acts as a organic coloring pigments. Organic coloring pigments. This is about the stabilizers. Okay, fillers, plasticizers, resins. Okay, resins forms a major part of the plastic to the resin. All these plasticizers. Okay, fillers, stabilizers, lubricants, accelerators or catalyst and coloring material added to give the desired shape to the plastic, desired form. Okay, the process of adding chemical admixtures which increase the physical properties of molded products is called as a compounding of plastics, which called as a compounding of plastics. Here Next, we have the preparation, properties, and applications of PVC, polyvinyl chloride, nylon 66, Teflon, okay, tetrafluoroethylene, okay, Teflon, and last one is bakelite. We have preparation, properties, applications of all these compounds. We need to discuss PVC, polyvinyl chloride, nylon 66, Teflon, okay, and bakelite. Okay, first preparation. Coming to the preparation, properties, and applications of polyvinyl chloride, PVC. Preparation, applications, and properties of PVC, polyvinyl chloride. How we are going to prepare this? Okay, polyvinyl chloride. It is a polymer. We have preparation, properties, and applications of PVC, nylon 66, and bakelite, Teflon. First one, PVC. Coming to the PVC, how we are going to prepare this PVC is polyvinyl chloride. Polyvinyl chloride is obtained by heating vinyl chloride. Okay, by heating vinyl chloride in presence of benzyl, small amount of benzyl peroxide or hydrogen peroxide in an autoclave under pressure. Okay, how we are going to prepare this polyvinyl chloride? This is a polymer obtained by heating the vinyl chloride. Okay, heating the vinyl chloride in presence of benzyl peroxide or hydrogen peroxide in autoclave. The pressure is polyvinyl chloride. Here, vinyl chloride is prepared by treating acetylene. Now, we need how we are going to prepare this monomer vinyl chloride. Vinyl chloride is prepared by here on acetylene. Acetylene formula CH triple bond CH. This in the reacts with hydrochloric acid HCl. It forms vinyl chloride. C double bond C H H H Cl. This is, we called it as vinyl chloride. This is the monomer involved in the preparation of polyvinyl chloride. Here, the presence of ZnCl2, zinc chloride, as a catalyst. Yeah. Here, how we are going to prepare this monomer vinyl chloride is acetylene reacts with hydrochloric acid in presence of ZnCl2, zinc chloride as a catalyst. It forms vinyl chloride. This is the monomer. This monomer vinyl chloride, okay, this monomer vinyl chloride reacts with, okay, it in the presence of small amount of benzyl peroxide or hydrogen peroxide in autoclave, and the pressure gives polyvinyl chloride. Polyvinyl chloride. Okay, here vinyl chloride is prepared by heating. Okay, acetylene reacts with hydrochloric acid. It, in the presence of ZnCl2 zinc chloride, it gives vinyl chloride. Vinyl chloride in the presence of, okay, obtained by polyvinyl chloride is obtained by heating vinyl chloride in presence of small amount of benzyl peroxide. Okay, this is the, okay, monomer, that is vinyl chloride in the presence of catalyst. In the presence of catalyst under pressure, it gives the polymer, that is polyvinyl chloride. Polyvinyl chloride, the formula is PVC. It is commonly called PVC, polyvinyl chloride. It is prepared by, polyvinyl chloride is obtained by heating vinyl chloride in presence of small amount of benzyl peroxide or hydrogen peroxide. Here, benzyl peroxide or hydrogen peroxide in autoclave under pressure gives the polyvinyl chloride. Okay, the monomer this polyvinyl chloride is obtained by acetylene reacts with hydrochloric acid at 60 to 80 degrees in presence of metal chloride, that is zinc chloride as a catalyst, gets the vinyl chloride. Okay, the monomer, that is vinyl chloride. Now coming to the properties and applications of PVC, polyvinyl chloride. What are the properties and applications of polyvinyl chloride? Here PVC is colorless. Colorless means does not contain any color, and odorless, smellless, non-inflammable. Okay, it is not flammable, non-inflammable, and chemically inert powder. Actually, it is a powder, chemically inert powder. Inert means it cannot react with any other chemicals. Chemically inert powder. Here it is a resistance to light. Yeah, here it is the resistance to, sorry. Okay, PVC is a colorless, odorless, non-inflammable, and chemically inert powder. Chemically inert powder, and it is resistance to light. Okay, resistance to light, atmospheric oxygen, and inorganic acids and alkalis, means bases, but soluble. But soluble in hot chlorinated hydrocarbons such as ethyl chloride. It is soluble in hot chlorinated hydrocarbons such as ethyl chloride. Ethyl chloride formula is C2H5Cl. It is soluble in hot chlorinated hydrocarbons such as ethyl chloride. Here the melting point of this PVC is 148 degrees centigrade. Melting point of PVC is 148 degrees centigrade. It is a strong polymer, strong and brittle in nature. Strong and brittle in nature. Here it is not stable. PVC is not stable to heat and UV radiation. Okay, to heat and UV radiation, it is not stable. It undergoes degradation. When PVC is kept in the heat and UV radiation, it undergoes degradation. Okay, these are the properties of PVC, polyvinyl chloride. Okay, it is a colorless, odorless, non-inflammable, and chemically inert powder. Okay, it is resistance to light, atmospheric oxygen, inorganic acids, alkalis, but soluble in hot chlorinated hydrocarbons such as ethyl chloride. And the melting point of the PVC is 148 degrees centigrade. 148 degrees centigrade. Here, this is a strong polymer and brittle in nature. PVC is not stable to heat and UV radiation. Okay, it undergoes degradation. It undergoes degradation. Coming to the applications, there are two types of applications: unplasticized PVC and plasticized PVCs we have. There are two types of PVCs: unplasticized, okay, or rigid PVC, or the unplasticized PVC have superior chemical resistance, and high rigidity, but it is brittle. Means, okay, here this type of unplasticized PVC is used in the making sheets. Okay, making sheets used for tank linings. Okay, in the tank linings, safety helmets, refrigerator parts, components or parts, and in the preparation or manufacturing of tires. Okay, rigid or unplasticized PVC have superior chemical resistance. It has superior chemical resistance, and we can use this in the making sheets, used in the tank linings, safety helmets, refrigerators, components, and the manufacturing of tires. Will use rigid PVC or unplasticized PVCs because there are superior chemical resistance and high rigidity, but it is brittle in nature. Coming to the plasticized PVCs, okay, these are obtained by adding plasticizers. Okay, okay, these plasticized PVCs are obtained by adding plasticizers such as dibutyl phthalate or triglycerol phosphate. By adding these plasticizers like dibutyl phthalate or triglycerol phosphate. By adding this triglycerol phosphate or dibutyl phthalate, okay, plasticized PVCs are obtained. Now coming to the plastic uses of this, okay, it is used in making sheets. Okay, making sheets, packing raincoats, tablecloth curtains, electric cables, toys, okay, radio components, plastic coated cloth, chemical containers, thermal insulating foam, okay, used in buildings, cinemas, aircrafts, etc. These are the plasticized PVCs. Okay, every examples are it is used in making sheets, packing raincoats, and tablecloth curtains, electrical cables. Okay, these are the cables, wires and cables. Picture radio components, toys. Here it is in the preparation of toys. Radio components, plastic coated cloth, chemical containers, thermal insulating foam. Okay, and that is used in buildings, cinemas, and aircrafts. These are the uses of plasticized PVCs. These are obtained by adding plasticizers such as tricresyl phosphate or dibutyl phthalate. These are the applications of plasticized and unplasticized PVCs. Plasticized and unplasticized PVCs. Okay, how we are going to prepare this PVC, polyvinyl chloride. Polyvinyl chloride is prepared by, okay, it is obtained by heating the vinyl chloride in presence of hydrogen peroxide or benzyl peroxide under pressure gives the polyvinyl chloride, gives the polymer, that is polyvinyl chloride. Okay, this here vinyl chloride is prepared by treating acetylene with hydrochloric acid HCl at 60 to 80 degrees in presence of metal chloride. Okay, zinc chloride as a catalyst. Okay, here you will get the monomer vinyl chloride. This vinyl chloride in presence of, okay, this is a monomer vinyl chloride. This is prepared by hydrogen peroxide. This is obtained by heating the vinyl chloride in presence of small amount of benzyl peroxide or hydrogen peroxide in an autoclave under pressure gives polyvinyl chloride. Polyvinyl chloride. Okay, this is the preparation, properties, and applications of polyvinyl chloride. Polyvinyl chloride, and the properties are, okay, these are the properties. PVC is a colorless, odorless, and non-inflammable and chemically inert powder. It is resistant to light, atmospheric oxygen, inorganic acids, and alkalis, but soluble in hot chlorinated hydrocarbons like such as ethyl chloride. Ethyl chloride formula is C2H5Cl, and it has a melting point of 148 degrees centigrade. It is strong and brittle in nature, and it is not stable to heat and UV radiation. It undergoes degradation. The presence of heat and UV radiation, the PVC undergoes the degradation. And the applications are, okay, these are the unplasticized PVCs and the plasticized PVCs applications. Okay, unplasticized PVCs have superior chemical resistance, high rigidity, but it is brittle in nature. It is used for making sheets, used in the tank linings, safety helmets, refrigerator components, tires, etc. Coming to the plasticized, it is used in the making sheets, packing raincoats. See, this is the raincoats, cables, plastic coated cloth, chemical containers, thermal insulating foam, that is used in the buildings, cinemas, and aircrafts. Okay, these are about the applications of PVC to unplasticized and plasticized PVCs. Have any doubts, you can. Preparation, application and properties of PVC, polyvinyl chloride. If you have doubts, you can ask me. Preparation, properties and applications of PVC and compounding of plastics. Yes, any doubts, ma? Any doubts in the compounding of plastics and preparation, properties and applications of PVC? Preparation, properties and applications of polyvinyl chloride. Next we have nylon 66 and Teflon and bakelite. If you okay, we have preparation, properties and applications of PVC, nylon 66, Teflon and bakelite. Yes. Yeah, any doubts, ma? In the next class, we'll discuss the preparation of nylon 66. I am stop sharing the screen, ma. Thank you, one and all.